pause this, and away we go. So we're going to go through half planes. Now, we looked at inequalities. It's basically sketching inequalities. That's what it is. Now, if you think about an inequality, we know that this is less than, and this is greater than, and this is less than or equal to, and this is greater than or equal to. And we've sketched them on number lines. Now, of course, we need to be able to sketch a region on a graph. It's not a line, it's a region, because, of course, if you're looking at the values greater than a line, for example, if I had if I had the graph of y equals x plus 1, that is just a line with an intercept of 1 and a gradient of 1. That is a line. But what happens if I replace that equal sign with an inequality, such as, let's say, y is greater than or equal to x plus 1? Well, what would that look like? Anything that is greater than x plus 1 is actually going to be a region. Like so. And then we have to ask ourselves, is it inclusive? Yes, it is. We're including this point here. So that line is inclusive of that region. If I was to, however, have y is less than or equal to, then that's going to be this green section here, under the line. So it certainly helps if you can sketch lines, but of course we are looking at regions, not looking at a line itself. Now sometimes our inequalities can have two variables such as this, and for this, in order to be able to sketch that, you really need to be able to solve for y, don't you? Just like we've done before. Now, you can use your graphics calculators if you wanted to do something like this, but just remember that you may not be able to have a graphics calculator for that section of the test. So if I was to solve this for y, I'll show you just quickly what you could do in your graphics calculators, because I want you to get to know how to use them. 2x minus 3y is greater than or equal to 5. You can actually solve that. Now, if I can solve that by hand, we're dealing with y. What would we do to both sides? We want to subtract 2x from both sides, which would give me minus 3y is greater than or equal to 5 minus 2x. Okay, now I wanted to solve for y, so what do I do to both sides? I need to divide by negative 3. Now, what did we say? When I divide through by a negative number, I have to switch the inequality, don't I? So we're going to do that. That means that we've got y is not greater than or equal to. Whenever we divide through by a negative or times through by a negative, the same thing, we switch the sign around. Let's break this fraction up. That's the same as 5 over minus 3, or minus 5 over 3, and that is plus 2x over 3, if you like. Now, if I wanted to solve for that, though, if you wanted to do a bit of a shortcut and you have a graphics calculator, I could show you that we can say that, oops, that's a pretty funky looking graph that you don't need to see right now. We go to solve, menu 3(1), and you can not only solve equations, you can solve inequalities. 2x minus 3y is less than or equal to. Now, first of all, you see where the equal sign is here? You can press Control equals. This is definitely going to help you if you're doing sort of further maths or methods. And we're going to be solving that. And we're going to solve it with respect to what? With respect to y. Okay, we want to get y in terms of x. And you can see there that y is greater than or equal to 2x over 3 minus 5 over 3, which is what we've got here. Is that making sense so far? Now, if you can't do it with your graphics calculator, that's fine. I can show you a little bit later, but I just thought I'd just show you that now. Another thing you can do in your graphics calculator is this is a region, and if I press the home button and I go to sketch the blue one, which is the graph, and if you have a look here, this f of 5, this is actually my fifth function in my graph. If I press the delete button, if you've got a graphics calculator, you can try this. Press the delete button and what happens? It changes it to this. Now be careful, this is y. It has to be in terms of y. So really this is y is equal to. We're going to change that to y is greater than or equal to. Because we had this. Oh, no, sorry, it's less than or equal to. And so we've switched the signs over and we've got negative 5 over 3 plus 2x on 3. So we're going to go here and we're going to do that and we're going to go negative 5 over 3 plus 2x. Well, let's just do something here. Let's put that as 2x and let's put that as 3. And it should show you a region. Hopefully. It does. Look at that. So, in order to sketch a region, what do you have to do? Well, the first thing is you need to rearrange the equation just like we've done with inequalities already in section 1D. Yeah, you had a question, Josh?
Right, it's not so much a question, but could we just find the line and then if it's greater than or less than, could we just sketch above or below the line?
That's exactly right. That's what you're doing. Yeah. The problem is, though, a lot of the time is actually getting to this point without a calculator. Okay? Now, and you're absolutely dead right. The problem is, though, you notice here, so Josh's question is, can't you just find the line? Absolutely, but remember that over here it appears, can you see that we started with a greater than or equal to sign? And then over here, we've all of a sudden got a less than or equal to sign. So as long as you can get from this point where we're solving for y without a calculator to that point, absolutely no problem. That's the same as sketching y equals 2x over 3 minus 5 over 3, but we're looking at the region below it or above it. In this case, I've put in the wrong one. It's actually supposed to be less than, isn't it? So I've sketched the wrong one there. So you can see there that I've sketched the region above. If I was to press tab, okay, I want to sketch the region below, and the region below is also going to be coloured in. So negative 5 over 3, and then we've got plus control that 2x over 3, and we are going to get the region below, which is the green one. So we're after the green one. So you've got to then decide, is it above or below? Is it inclusive? Is it non-inclusive? Did you have a question?
Yeah, so basically all you need to look at is that, not all these numbers.
Absolutely. Yeah, so you've got to look at the inequality. So first of all, I thought I'd show you how to do it with a calculator. Now, so as we said, first we graph it, don't we? We graph the line. So this line here, we start with 4x minus 3y greater than 12. You've got to rearrange that. And then what we need to do is eventually, if you want to work out whether it's above or below the line, we can also do what's called a shade test. Okay, we could pick a point. For example, with this one, what is the point? If I know it was above the line, a nice point to pick would be the origin, 0, 0. If that was included, or if we did a test on that, and it included 0, 0, then we know clearly the region would have to be above the line rather than below it. So I'm going to go through and do a bit of an example of that. Is it a solid or a broken line? Well, if the inequality is less than or equal to or greater than or equal to, then we use a solid line because it's inclusive of the point. If it's not, then we use a broken line, which is going to look like something like this. Yeah, you had a question, Kate? I'll just...
I don't really understand what's like.
So we're sketching regions, which is or planes. All right. So as I said, whether you've got a line, whether it's greater than or equal to or greater than, in this case, you can see that this is what it would look like. This is how you would sketch it. If I was sketching y is greater than or equal to minus 3x plus 6, it's the same line. We still have the same intercepts, and of course, we're looking at the region above the line in this case because it's greater than in both cases. But because this one is non-inclusive, we would use a dashed line. Okay? So you can see there that if you can sketch the graph of y equals minus 3x plus 6, you can also sketch the graph of y is greater than or equal to minus 3x plus 6, or greater than. Yes?
Is it possible to find simultaneous equations like when it's equal to or greater?
We're not going to get to that quite yet, but yes. So similarly, for less than, it's going to look like this. Now, we won't go through intersecting regions just yet, but let's have a look at sketching this half plane. Now, I'm going to pause this. I'd like you guys to have a go at it. Step 1 is to sketch the line as though the equal sign never existed. Okay, oops. So step 1, sketch the line without the equal sign. That's what I think would be the best. Without the inequality, sorry. So that's step 1. I'm going to pause this and you guys have a go at it. Then we have to work out 1. Here we go. First step is we sketch the line. We did that in year 9. I have sketched the line, and that's without the inequality. However, we then look at the inequality. It's greater than. And of course, because it's already, since the inequality is already in terms of y, we have to actually, we don't have to do any hard work. We just have to look at the inequality and ask, is it greater than, or is it less than? Is it inclusive? It is non-inclusive. So therefore, that line must be a broken line. In other words, this thing here, the broken line. So what we need to do is get our eraser out and make that line needs to be a broken line, doesn't it? Now, of course, if I was to sketch that line, I would find that I have an x-intercept of 2 and a y-intercept of minus 3. And I'm not going to go through how we got that, because that should be already assumed knowledge. But now we're looking at the region greater than that line. Now, this is what I'm talking about, a test, to find out whether you've got this correct. If I've had to do some manipulation and some algebra to get y in terms of x, what we can do is we can test. Let's do a little test. And the easiest point is 0, 0. The origin. Let's do a test. According to my graph here, is the origin inclusive of that region? Yes. So, let's do a test. When x equals 0, we do know that y equals 0 at the origin, and we do know that that is supposed to be included in our region. Let's do that. Let's substitute that into our inequality. Is 0 greater than or equal to 1.5 times 0 is 0. Is 0 greater than minus 3?
Yes, it is.
Yes, it is. So, if this answer is true, it means that it actually includes that point. Does that make sense? So therefore, we've got the right region. We know that we can stop there. I'm just going to pause it just for now. I'd like you now to have a go at this one. Have a go without me. There's going to be a couple of questions here, so I want to get around the room and answer those. So have a go at sketching these inequalities on the same axis, please. Okay? Now, first of all, step 1. You've got to rearrange in terms of y and pretend the equal sign isn't there. Step 2, so sketch those two lines as if there was no inequality. Finding your x and y intercepts would be ideal, but for the time being, I'm more just worried about sort of getting those regions. And then after that, we then have to look at the inequalities. A less than or equal to sign, below that. However, if I need to divide through or multiply by a negative number, I do have to consider the signs changing. So away you go. Have a go at that. All right, so just quickly, I've drawn these lines here. And as you can see, these are just the lines. We're not dealing with the inequalities yet. However, once I've done that with my intercepts, we now need to consider, well, are we looking at the region above or below each line? Now, for starters, when I did this, when I rearranged this equation here, I didn't have to go flipping any or dividing through by a negative number, did I? So therefore, the sign remains the same. This is what we're looking at. We're sketching that region. So then we ask ourselves, is it inclusive of that line? Yes. Is it under the line? Yes. How can we tell? How can we do a test that it's under the line? What should it include that origin? Yes, it should. So if it includes that origin, we could do a test, couldn't we? Thank you. We can test 0, 0. Because if we test that point, then we know that we're talking about the region below the line. Let's do that test. Let's substitute. Is 0 less than or equal to 12 minus 4 times 0, which is 0? Is 0 less than or equal to 12? Yes, it is, which means that we are looking at this region here, aren't we? And it is a solid line because it is less than or equal to. The second one is, if we look over here, no, thank you. The second one is this. We have to ask ourselves, is that a broken line or a solid line? It is a solid line. So what we need to do is replace that, and that is a broken line. And we're looking at the region greater than. The region greater than, is that going to include the origin? No, it's not. So therefore, we could do a test. We could test the origin again because it's a nice, easy 0, 0. Let's test that out. Let's substitute. When y equals 0, is that greater than or equal to 3 times 0? Oops, my thing's gone nuts. Is 0 greater than 1? No. So therefore the origin is non-inclusive, and if the origin is non-inclusive, then we are above the line. But we're looking at the wrong one, aren't we? What is above the line? What is above the line? It's actually going to be, and I'll get my little highlighter out. Above that line, but non-inclusive, is going to be this. No, it's not. It's going to be... So just quickly, our answer is that. We've done a test, and our test is at testing the point origin. Is it inclusive? No. So we know that it's that region above. I'm going to stop there.